Dear students, welcome to the online class. I am Dr. SSC Hiramat. In this video, you are going to study about the wet adsorption isotherm. You know, friendly adsorption isotherm is an empirical equation or an empirical isotherm. And Langmuir adsorption isotherm was derived based on some assumptions or the postulates, and it was applicable to the monolayer adsorption of gases on solids. Now, the Brunner, Emmett and Teller in the year 1938 derived an equation for the multi-layer adsorption of gases on solid surfaces, and this equation is known as the wet adsorption equation or wet adsorption isotherm. Now about its postulates. Adsorption of gases. First one, adsorption of gases on solid surfaces is of multi-layer of gas molecules. Then second one, there is equilibrium between one layer and its successive layer such as a gas plus surface forms single complex, and this is called first layer with equilibrium constant K1. Then another molecule of a gas adsorbs on first layer and forms second complex or second layer with equilibrium constant K2. And another molecule of gas adsorbs on second layer forming third complex, or this is called third layer, and this is with equilibrium constant K3. In this way, one molecule adsorbs on the free surface at the site and forms the first layer, and on the first layer another layer adsorbs and second layer is formed, and another layer of gas molecules adsorbs on the second layer and the third layer is formed. Then third one, interaction between adsorbate and adsorbed layer is negligible or it is neglected. Means formation of the successive layers, the interaction between the layers is negligible. And fourth one, formation of single layer, formation of single layer is similar to the Langmuir adsorption theory. Langmuir's adsorption theory. And fifth one, about the forces that produce condensation are responsible binding energy of successive layers. Then sixth one, that is the heat of adsorption. The heat of adsorption of first layer is equal to the latent heat of condensation. Based on these postulates, the scheme of multilayer adsorption may be shown as follows. Scheme of multilayer adsorption. Suppose the hollow sphere indicates gas molecule, and a dot indicates vacant sites. Suppose this is surface area. It has number of sites. One gas molecule adsorbs in this way and forms first layer, and suppose these are the vacant sites, and similarly another layer is formed and vacant sites are there. Other molecules are also adsorbed. Suppose this is first layer. Means when the gas molecules adsorb on the free sides, they form the first layer. Now when one gas molecule gets dissolved or evaporated, and it forms the free site, and when it is condensed, it forms first layer. Suppose this is equilibrium K1. There is equilibrium between the vacant site and first layer between the molecules. And suppose this is second layer is formed in this way. Okay, then gas molecules are there. Then if one gas molecule gets evaporated, then second layer becomes first layer. And when one molecule adsorb on the first layer, it forms a second layer, and that is with equilibrium constant K2. Similarly here, suppose second layer is there and third layer is formed in this way, and one gas molecule, if it dissolves, it forms the second layer, and if it condenses over this or adsorbs over this, and the third layer is formed. In this way, there is equilibrium between them, and this is second layer, and this is third layer. Thus, when free sites occupy the adsorbate, first layer is formed, and first layer absorbs adsorbate, second layer is formed, and second layer adsorbs another molecule, third layer is formed. And in this way, there is equilibrium between the free sites and first layer, and there is equilibrium between the first layer and second layer with the K2, and there is equilibrium between the second layer and third layer. In this way, there is a multi-layer adsorption, and one layer and its successive layer are in equilibrium with each other.